Yep. Since you want to see some Python skills of mine, and I don't know what you expect from me to do, because it's a little bit blurry from the description of the job, but at least I can show from over 100 repositories which ones are Pythons, and I can walk through some of them, at least the newest ones, and we can see there my Python skills and which this of projects suits your needs more. We can discuss and continue with that. This is the crypto analyzer that I written lately. It's a tick data collector from Binance, and it's a very delicate project. All the details are represented basically in the GitHub page, but I can also walk through how did I started this and what is the purpose of this collector. Basically, the first Python file that I wrote is WebSocket collect. Here I am listening the WebSocket of the OKEx marketplace like this, and here I declare instruments. From the API document I gathered the ticker numeric columns here, and I wrote some conversion functions. I mean, these functions is necessary because in this WebSocket collector I intended to how do I collect without using another Python library, just pure socket connection. And after that I collect the data. I will load that data into a Postgres database. I will do it continuously day after day, 24/7, until I gather right amount data, make the machine learning can analyze this tick data into trading. So basically I wrote an OKEx ticker client here, and it has the subscribe and a read forever function, and reads foreverly while OKEx market is broadcasting the data to the internet, and it prints into a pandas data frame here, as you can see, and just prints out the pandas data frame into the terminal. So this was a basic experiment and a POC, proof of concept, the early stage of this project. So this project started and evolved to the tickers to Postgres Python file. Here I have implemented some kind of Windows event loop fix because side pop async functions works differently than Linux in Windows. So let's pass over this. It's a little bit technical. So here now what was my intention is now to collect the data, not just to print to terminal. Instead of printing into the terminal, I will record it to a database. So because of that, there is a connection info here, as you can see. So there is a scheme. There is a OKEx and BNC. BNC is the Binance scheme because they are different. And here I want to collect different marketplaces and different data types and store them into the same database. Then after right amount of data is collected, I will compare them and try to find the differences between. So there is a Python 3.8 compatibility issue here. Also there are helper methods, the conversions to integer to decimal, and date time to date time conversions, Binance to OKEx symbol conversions. Basically Binance doesn't put dash between symbols. So there is a database creation objects also here, both for the Binance and OKEx, and there's insert functions here, another normalizer here, and another normalizer for Binance. And yeah, also I intend to record the order book into the Postgres database. So these functions, order book functions, was necessary. So database bootstrap here, I ensure the database is created and out there with the exact scheme that I have to record. And there is a base writer here. As you can see, the base writer is collected data will be recorded in a separate thread to the database. So when I run this one, it will record in batches to the database, the actual data. So on top of this, I can build with inheritance the OKEx ticker writer and Binance ticker writer. So object-oriented software over Python experience, you can say. And there is an order book writer too. So there are WebSocket clients, as you can see here. The OKEx client is different than the Binance ticker client. In the end, there is an OKEx order book client. So in the main function, as you can see, I will execute the database creation and ensure the database is created here. As you can see, I'm initiating the writers for Binance and OKEx. Optionally, if record order book is selected, I will initiate an order book writer here too. At that point, asynchronously, I create an OKEx ticker writer and Binance ticker writer side by side, and I'm using the multi-threading and putting the data from the WebSocket, both Binance and OKEx, into my database. There is a gracefully shutdown events here, and I close the clients and writer here and cancel the tasks and quit. So this is running asynchronously until I hit Ctrl C and stop this. Tickers to Postgres Python. Then I will start with open close, open high, low close API. I mean, this is a web REST API basically. While we are recording the tickers to Postgres, we can read from a service like MacBook server. This is my home server, by the way. Within the schema of OKEx and Binance, it reads data and broadcasts the data for any kind of user interface. Basically, there are helper functions here. There is a get endpoint. There is a tick chart endpoint here. I mean, example queries are here, like tick chart symbol BTC USDT period 100 means you will get 100 period tick chart. By the way, I am not telling and skipping here. There is a function, a database function that consolidates all the ticks from Binance and OKEx into the a tick chart, like consolidating them within a period, like here in the example 100. So it makes 100 ticks in a candle. So if we say 1000 ticks, so a candle means 1000. So basically this is the web service and pure in Python. After that, of course, there is a consumer. Index HTML is basically a DevExpress HTML page that consumes all Python written candle provider and prints out to the candle chart of DevExpress. Basically it's JavaScript, and as you can see there is a venue selector. You can select Binance or OKEx. I will make a demo of it, then it will be much more understandable. Right now it's a pure JavaScript, it's hard to follow, but I will say it one by one. There is a symbol selector. You can select the collected symbols. By the way, I am collecting Ethereum and Bitcoin data. And there is a period selector here, as you can see. You can select in between days from and to. So a period selector, you can, as I mentioned before, you can select the period 10, 100, 1000, 10,000. I mean, each period means we are collecting into a candle that much. Date range with time is calculated here. A range box there is, and there is a submit button. There is a width controller. I put this to visualization purposes because if the chart is getting longer, you can increase the width of the chart, then scroll right and left and examine and compare Binance and OKEx data. And there are charts, the Express chart code in JavaScript basically, and there is a toggle chart capability, because if you don't toggle them, comparing them will be. There is a refresh chart function in JavaScript here. So it's finished. More to that into this project, I have also added train next close and train next close multiverse plus and different kind of training systems. This is an LTSM to predict the next open high low close bar closing using from the FAST API. So in the documents, first I want to share what is the output of this. This is the output of what we train. So the blue line is the actual and the orange line is the predicted line. So this way I am training a neural network to predict next peak time price if it is able to predict. So if we go back, what is the actual code? The actual code is very easy. Now we are fetching data from our API. Previously, this open high low close API Python file is running on the server. So we will fill into the data frame of pandas, the tick chart, and we will make it supervised. We will split data and scale. We will build a compact model with 64 nodes and a dropout and dense layer. I mean, this terminology is a Keras terminology, and this will be a Google TensorFlow model, and in the end this will be, or how can I say, the neural network, and built with Python. I mean, I'm representing this project because this project includes many things here. We have API, we have WebSocket listener, we have database writer, how can I say, we have database migration, and also we have TensorFlow training. So we will evaluate predictions here. So in main, there are parameters. We will say the API venue, symbol and period, and with different parameters we will record different type of prediction, and we will compare the direction accuracy and error accuracy. Okay, let's see it now. So into the database, if we go to database, we can see the schema of Binance and ticks in the public. Also, we have machine learning evaluation tables. So if we go and count the database according to the ticks, we have 2 million OKEx ticks and 200,000 Binance ticks here. So if we go to function, there is a function in both schemas. If we go to functions, we can see the ticker open, high, low, close function here. As you can see, this is a grouping function according to the period. So if we go back to queries, here we can count 100 bars period. Now we can see it's reading data from our database, and it's from OKEx marketplace, and it's from Binance Market. So let's see if our service is working over this Postgres database in Python, and if our JavaScript user interface working or not. Let's go to this server with SSH and let's run some screen here. So we will create new screen, and if we go inside our folder, crypto analyzer, we see the Python project here. We can run virtual environment. Inside our virtual environment, we will run the ticker collector. Yep, the pool is open. Now, from the OKEx and Binance, we are collecting Bitcoin and Ethereum data inside our database. And let's go back to our database and let's see our counts are increasing. 2 million, and it's increasing, as you can see. So if we go back to our Linux screen, we will create a new screen. We will go inside our folder, we will start again virtual environment, and we will run the services with Unicorn application on the host of 000, which will be our network server, and the port will be 8200. Let's start it. Yep, it is up and running now. On top of this API, we can start now our Python project JavaScript endpoint with DevExpress charts. Let's create another screen and go inside our crypto ticker analyzer. We will activate the virtual environment. We will start a Python HTTP server to host our user interface on port 8201. If we go back to our browser, we can call MacBook server 8201. And immediately it will bring up our user interface candles. Yep, here we are. Let's create a compare and meaningful data with longer ticks, and let's compare the OKEx Binance. Let's submit it. Yes, here it is. Now we are gathering candle data. Yeah, this is, and we are comparing with the Binance data. As you can see, the Binance data is less frequent than OKEx data, and the frequency of the data is very high in OKEx. This caught my eye. So in the end, finally, we are seeing a pure Python project, a WebSocket collector, an API, and JavaScript user interface with DevExpress charts. Oh, by the way, I forgot to show also the machine learning part of it. We can go inside our virtual environment like here. Yeah, it needs to be pulled. Let's check out the develop branch because machine learning part develop branch thing. Yep, so let's go back here and see some examples. Let's train our model with higher period. Then it will give some install the requirement contents shortly. All necessary packages has been installed. Now it should be training over Ethereum data with period of 10,000 in 10 epoch. Let's see it goes. It's fetching data from our MacBook server itself. Here, me decrease a little bit period. That's better. Now it's trained, and there are test metrics here. There is a picture. So that's our training. We can also train our Bitcoin like 20 collector. Both of bar now itself is a predict. So that's it. Thank you. That was my all the Python knowledge combined in a single project. And lastly, I will share this link of the crypto tracker analyzer on my GitHub with very detailed with trading.